Yes, hello, hi, welcome all of you to EDUHUNT IIT and NEET Foundation classes. This is Sukumar, your chemistry mentor. See, in this particular video, I am going to explain the concept called resonance. The concept called resonance. See, in the very beginning of chemical bonding chapter, I already used this word while I explaining the concept of Lewis structures. Again, now I want you to recall that concept called Lewis dot structures, because only by understanding that concept you can better understand this resonance concept. How? Let me explain. See, in the very beginning of the chemical bonding chapter, I told you several times, whenever there is a formula in front of you, you must be in a position to propose a structure to it, right? You must be in a position to propose a structure to it. Structure means connection. Again, I am telling you, structure means connection. What kind of bond present between the atoms? I am not talking about shape. I am talking about structure. Structure means connections. Okay. So, for that approach, to propose a structure to any formula, any given formula, in general, fundamentally, the Lewis dot structures is very useful, right? And after that, representing the entire structure with dots becomes a hectic process. So, we replaced that Lewis dot structure with Kekule structures. Okay? We replaced Lewis dot structure with Kekule structures, and in our previous classes, I explained what is the difference between Lewis dot structure and Kekule structure, and again I'll explain now also. Please follow. See, for suppose, if you are having a chemical species in front of you as a formula, CO3 2 negative. I hope you know the name of this ion, carbonate anion. The name of this ion is carbonate anion. Okay, fine. Now the task is, we need to propose a structure to it. That means we need to propose how carbon is connected to rest of three oxygens. In what way it is connected, what kind of bond is present, like that. For that, we already studied a procedure to propose a Lewis dot structure to it. I hope you remember that procedure. Again, I am doing it for you. See, first of all, calculate valence electrons. In the entire species, calculate only valence electrons. How many valence electrons present? Carbon is having 4 valence electrons in its valence shell. Carbon 2s2 2p2. Oxygen is having 2s2 2p4. That means 6 valence electrons. 3 oxygens are there, na? 3 oxygens are there. 3 6 are 18 valence electrons. 18 valence electrons, and there is 2 negative. It means 2 extra electrons present in the form of the charge. So take that 2 electrons also. A total of 24 electrons as valence electrons present in this entire species. 24 valence electrons. Now what you need to do, keep this value safe and use a formula called P is equal to 6n plus 2. You know very well. I'll explain what is the purpose of this formula. P is equal to 6n plus 2. You can take P for pi electron or P for pi bond calculation. Okay. And what is n? N is the number of atoms in this entire species. I hope you know. You can see that there is 1 carbon, 3 oxygen, a total of 4 atoms. So N is the number of atoms and P is for pi bond calculation. You can take like that, no problem. And while calculating that N, keep in mind, don't include hydrogen if present. Okay, keep that in mind. Yes, don't include hydrogen in the calculation of that N value I am telling. Now do it. Calculate P value. P is equal to 6 into how many atoms total? 4 atoms. 6 into 4 plus 2. 24 plus 2. You are getting P value 26, valence electron value 24. Now, using these two values, you can calculate number of pi electrons, number of pi electrons. See, this is the one way of approaching Lewis dot structure. See, this is the method in which I am comfortable. I'll train my students. Okay, I'll try my students with this method, and there are so many other methods, but all are correct. Okay, you can approach Lewis structure for any given species if it follows Lewis theory very well with this method. So what you need to do in the beginning, you calculate the entire valence electrons, and then you calculate the P value. Now you calculate the number of pi electrons by using these two values. How, sir? How I can do, sir? Yes, P minus valence electrons. P minus valence electron. That means you are getting 26 minus 24. That means you are having 2 pi electrons. 2 pi electrons. And you know that if there is a double bond, it means there is 1 sigma 1 pi, and if it is triple bond, 1 sigma 2 pi, and it is single bond means always sigma. You know very well these basics. Now observe carefully. In a pi bond, how many electrons? 2 electrons. 2 pi bond means 4 pi electrons. It means every 2 pi electrons can form only 1 pi bond. 2 pi electrons, 1 pi bond. 4 pi electrons, 2 pi bond. It means number of pi bonds is equal to number of pi electrons by 2. That means there is 2 pi electrons. It means in this particular case, I can write here. In this particular case, I can say that there is 1 pi bond. Okay, 2 pi electron, 2 by 2, 1 pi bond. Okay, so keep that data in mind. Now try to approach the structure of this species. How? Now take carbon as a central atom. By instinct you know it as a carbon as a central atom, or in general we can say that in that entire species the atom with the least electronegativity can be taken as a central atom. Okay, or you can try by taking oxygen as a central atom, then you will realize that it is wrong. Okay, yes, anyhow, now there is 3 oxygens. I am making 3 oxygens randomly like this. Sir, how can you write this? How can you write oxygen at this place, sir? Why not at this place, sir? See, we are not concerned about the geometry or shape here. We are concerned about only the connections. If you want, you can write in any places, but in the original Lewis theory, actually Lewis proposed all the structures either in linear way or right angles, but Lewis doesn't care about the geometry. Okay, while we are proposing Lewis dot structure, you also please don't care about geometry or shapes, just the connections are important. You just make linearly or right angles. Okay, now it makes a simple sense that at least there must be one bond between every 2 atoms, right? There must be one bond, no doubt about it. There, I'll write here, carbon, oxygen, there must be one bond, na? Yes, make one bond between every 2 atoms like this. One bond, no doubt about it. There must be one bond. Now use that pi bond You calculated. You know that in this species there is one pi bond. In this species there is one pi bond. Yes. Sir, where can I draw that pi bond, sir? Yes. You can take that pi bond here or here or here. I am taking chance. I am taking the pi bond here. Okay, fine. You can take that pi bond here or here, or there are three possibilities, na? But I have taken one possibility. Keep it. Okay, fine. In this entire process, how many valence electrons I have used? 1, 2. One bond means a pair, na? 1, 2, 3, 4, 5, 6, 7, 8. 8 valence electrons we used, but you know there is 24 valence electrons. So among 24 valence electrons, we used 8. Now how many left? Left with 16 valence electrons. We left with 16 valence electrons. Now what to do these 16 valence electrons? What to do with these 16 valence electrons? You have to distribute these 16 valence electrons to all the atoms. You have to distribute them. Sir, how can I distribute, sir? Is there any rule, sir? Yes, there is a rule. You can't distribute by your wish. There is a rule. You have to distribute these 16 electrons to all these 4 atoms in such a way that every atom is getting octet. Every atom must have 8 electrons in its valence shell. That way you have to use these 16 electrons. Okay, I'll do. See, I'll explain. See this oxygen. This is having how many electrons? This oxygen is this oxygen and this carbon is sharing this pair, na? That means this oxygen is having this electron pair. You have to consider like that. Yes, this pair 1, 2, 1, 2. 3, 4, 5, 6, 7, 8. Now octet completed. That means to complete octet for this atom, I have used 6 electrons from here. Now I left with only 10 electrons. If you are not able to follow, you can rewind the video, na? Yes, okay. If I am little bit fast. Yes. Now similar situation for this also. Use 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Fine? Yes. Now octet completed. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Both the atoms completed their octet. Okay. Among these 10 you used 6. Now you left with only 4. Now think about this one, or think about carbon. 1, 2, 3, 4, 5, 6, 7, 8. Carbon doesn't need anything. Already its octet completed. Okay, fine. Think about oxygen. 1, 2, 3, 4. 4 only. 5, 6, 7, 8. Give that 4 electrons. Khatam. So what you did? There is a procedure you need to follow. There is a procedure. I have explained this concept in the beginning, in the first few videos, where I explained Lewis dot structures. But again I am explaining because you may forget, because after few concepts we are here, na? Yes. What is the procedure? First calculate valence electrons, calculate p-value, subtract valence electrons from p-value, you will get number of pi electrons. Number of pi electrons gives you number of pi bonds. Make the atoms at right angles or linear way. Make at least one bond. Now take that pi bond. Take that pi bond among at any one possible place. Take that pi bond as a double bond. Now how many electrons you used? 1, 2, 3, 4, 5, 6, 7, 8. 8 used. Among 24 valence electrons you used 8. You left with 16. Now what to do with that 16 electrons? You have to distribute that 16 electrons in such a way that every atom must get 8 electrons. Every atom must get 8 electrons. Okay, fine. Now carbonate is the anion, and following what Lewis said, we proposed structure to this carbonate. Now in the scientific community, if this structure has to be valid, the proposed structure has to be valid, this structure properties or this structure must explain the practical values or practical observations of the carbonate anion. That means there are some studies like X-ray studies, crystallographic studies, spectroscopic studies. You will know about them in higher studies. Okay, in that studies whatever data they got about carbonate, that data must be consistent with the theoretical structure we propose. Otherwise we have to rethink about the theory which we believed that every atom is trying to get octet, and basing on that we followed this procedure and you proposed the structure. If carbonate is really existing in this structure must explain every property of carbonate which is obtained practically also. Are you getting my point? Yes, but that was not happened. That was not happened. Practically scientists got that in carbonate there are, I'm telling one of the points, okay? Practically there are so many points regarding this one. One important, practically scientists got that in carbonate all carbon oxygen bonds are same. Practically they found that in laboratory by doing some experimental procedures, some tests, okay, they got to know that in carbonate all the carbon oxygen bonds are same type practically, really. But in this structure what we proposed that in carbonate there is two kinds of CO bonds, one single bond and one double bond. But in reality is different. Reality, carbonate is having all CO bonds of same type, same length, same strength, same type. How? Now there is something we need to think about. Yes. We need to think about something. We need to know about some other concept which we are missing here. And that concept is nothing but resonance. And that concept is nothing but resonance. Sir, what is resonance, sir? Yes, let me tell you. See, after making one single bond each, now I got a chance to give pi bond at 3 positions. I told you already, you rewind the video and watch again. I had a chance to make pi bond here. I can make double bond here. I can make double bond here. I can make double bond here. To make double bond, I have 3 options. But I have taken only one option and proposed this is the structure. How? This double bond can be present here or here. Even if you propose the double bond here, that is also correct according to Lewis. Even if you propose structure double bond here, that is also correct, and this is also correct. All the 3 are correct, right? Yes. Now to try to do it, shall I erase this part? I can use this. Now carbon, oxygen, minimum one bond. Now I had a chance to make pi bond. In one case I have made pi bond here. In another case I will make pi bond here. Who stops me? Nothing wrong. Now supply the valence electrons just like this. Now according to Lewis, this is also the structure of carbonate. Yes, this is also correct. Now I can take that pi bond at this place also. Yes, you can do that. No one can stop you. Carbon, oxygen, single bond. Now use your option, third option, you can make pi bond here and supply rest of the valence electrons as you did previously. Now you see this, I asked you to propose structure for carbonate and you proposed 3 structures, right? You proposed 3 structures. Now the question arises, sir, okay, you are saying according to Lewis theory all the 3 are correct. Now the point is, which one is carbonate? Is this one or this one? The point is these are all called resonance structures. These are all called resonance structures. Among these three, no one is the original carbonate ion. No one is the original carbonate ion. Now, which one is original? Which one is carbonate? The original is the resonance hybrid of all of the three. All the three will intermix in imagination. You have to do it in imagination, in reality not. Okay? In your imagination, you intermix all of them. You intermix all of them and give a hybrid. That means, how can I do it, sir? Yes, I'll help you. First, make the bonds and the atoms which are not disturbing. Carbon atoms, oxygen atoms, and that single bond is not disturbing. But that pi bond, at one point of time in one structure you proposed pi bond here, pi bond here, pi bond here, and pi bond here. That example. That means every bond, this bond or in this structure, this bond is having single bond character, and here it is having double bond character. It means what? It means what? This bond is having a partial double bond and single bond character. That means you have to make a partial bond character. It is more than single bond and less than double bond. That's the hybrid. Double bond, single bond, single bond. That means it is more than single bond character, less than double bond character. The hybrid, yes. So the point is, carbonate is the actual original structure is the hybrid. And what about these are all the three resonance structures or canonical structures. Resonance structures or canonical structure. And do remember, these three are not real. These three are not real. The point is to propose, when you are going to propose a structure, when one structure is not sufficient, you can write these points in running notes, okay? When one structure is not sufficient to explain all the properties, we propose more than one structure. Again, I am repeating for you to note down comfortably. When one structure is not enough to explain all the properties of a chemical species, we propose more than one structure called resonance structures, and the original is the hybrid of all the resonance structures, and this entire phenomena is called resonance. Okay, and here there is one double bond, and always see here there is one double bond, so you can draw the structure separately, but when there is more than one double bond, it becomes difficult to distribute the double bond. Then we chemistry people, we follow a procedure by shifting the electron pairs. How? I'll show you. Imagine that this pair has shifted here like this. This pair has shifted. When pair shifts, it becomes bond. Pair shifts, it becomes bond. Then this carbon gets how many bonds? 1, 2, 3, 4. Already 4 bonds. And this pair shifts 5 bonds. So then this pair shifts like this. When pair shifts bond shifts pair. That's the structure. So this kind of shifting gives this structure. Okay, and don't take it wrong that this structure is derived from this one. Of course, on paper we derived this structure from this by shifting the pairs like this, but in actuality these are not real structures. They will exist only on paper. It is our limitation that with one structure we can't explain all the properties of a compound or a chemical species. We are proposing more than one structure. So these are resonance structures and one more name called canonical structures. I hope you understand.